Cool. So I haven't spoken for a prolonged period of time, for about 18 months. So if my voice does start to break, fail, etc., please bear with me. But you're all here because you are interested, at least, in creating your own resources on Kubernetes. So let's crack on once it starts working. There we go. So yeah, slight alteration to what Steve was covering. The obligatory who I am, what Kubernetes is, just so that everyone's on a bit of a level playing field, in case there are people here or watching this later who haven't fully got a grasp of what it is. They've heard about it, but that's about the limit. Go into Kubebuilder, so the crux of what this talk is going to be about, and then a live demo. You'll be pleased to hear I'm not going to be writing code because that's going to be incredibly tedious. It will just be going through and building upon sort of previous steps. So for those who know me, have worked with me, or been on other events that I'm involved with, I would like to apologize in advance for my dog, who is inevitably going to start demanding attention at any point in the next sort of 20 or so minutes. I didn't have enough time or skill to manipulate this reasonably famous video of some guy getting interviewed by the BBC and his kids bursting in through the door. So you'll have to forgive my fairly loose Photoshop skills. So now the apologies are out of the way. Who am I? Well, I'm Rich Hayes. I am the infrastructure team lead at Futrli. For those who are not sure what an infrastructure team lead is, that is a picture of me. I've been in the tech industry for a little over 10 years, started in the .NET world, doing some CMS-based, web-based projects, then moved on to Python and DevOps infrastructure, which has been the vast majority of my bread and butter. But in the last few years, I have gone on the Golang bandwagon. So we've been running some, Futrli, we've been running Golang in production for about 2 years now. And we're adopting it more and more for various number crunching components. If in the future we're creating some kind of integrated development language, DSLs, etc. And yeah, for the past 2 years, have been running our Kubernetes infrastructure, building and running our Kubernetes infrastructure. So before we get into it, this is going to be the leveler, a bit of a history lesson as to where Kubernetes originated from. So back in the day, you remember when that sort of weird multicolored search engine came online, and they were just doing search. Mad to think about it now, but you know, if you think about scaling the internet for search purposes, it's a massive challenge, obviously. This very high level diagram shows some components which may or may not have been in Google's search architecture. And that's fine, you know, there's, you know, the microservices world that we're kind of living in now, a lot of that stuff kind of makes, you know, a lot of sense. We need stuff to be able to serve these search pages. We want things to go off and scrape various pages on the internet so that we can transform and manipulate that into a data store which makes sense, so that we can perform analysis on it, so that when someone types in funny cat images, they are then presented with a whole bunch of funny cat images. and that's fine. But when you're talking about serving the world at a global scale, you haven't just got one database or a handful of crawlers. You've got trying hard not to swear, a metric ton of each of these entities, which need to live somewhere, run somewhere, need to be redundant, they need to be available, and it's a big challenge. And then there's that inevitable discussion of let's do other things. New product managers come in and say, oh, wouldn't it be cool if we did email, for example? So then there's a whole heap of architecture around that. More services, more servers, more storage, etc. And let's compete with Microsoft and do something Office-y as well. So services times number of products, again, globally. And screw it, let's just do all the things that we possibly can, because we are this absolute monolith entity steamrolling over the internet. So what kind of things go into making a Google? So you're going to have many. This is taken from a white paper. These are legit values against these entities. So they've got many clusters, and each cluster is going to have tens of thousands of machines, so tens of thousands of servers. On those clusters, there are going to be many thousands of applications, services, pieces of code that run them, however you want to define them. And then jobs, tasks, so asynchronous, go off and crawl this website or translate the Iraqi government page into searchable tokens that we can then serve up to people querying for the Iraqi government from Japan or Samoa or Canada, or language specific. So this starts to become a little bit of a headache. It's all it's all well and good managing like 5 EC2 instances on Amazon, but when you're talking about tens of thousands per cluster, it gets a bit it's a bit stressful. But as technology evolves, as things evolve, how applications run evolve. So if you look at over the last 30 odd years, your traditional deployment would be a physical server, and on that you would have your operating system of choice, and then you would run one or a handful of applications on that one server. So when you want to scale that out, you need to go down to eBuyer or Amazon, or well, this was before Amazon, but you know what I mean. You need to buy all of these servers so that you can then copy and paste via FTP your massive Java application onto the next box. And then a few years later, virtualization sort of showed up, which made it slightly simpler. You kind of had these units, these virtual machines, which make things a little bit more copy and paste friendly. As the kind of virtualization world evolved, being able to have control over a virtualized cluster made the scaling of applications and data centers and all that good stuff a lot easier. And then as everyone starts running on VMware and paying tens of thousands of pounds for their license, turn of the millennium, it turns out, after a bit of research, the Unix Linux kernels started providing the ability to have kernel namespaces, which essentially partitions resources so that you can use them without having to run a virtualization hypervisor, without having to have an operating system running on each particular entity that runs. And very, very quickly kind of became, you can throw hundreds potentially of applications on a single box very, very nicely, and have them all sort of secure and yeah. And obviously, because Google running on the forefront, they were using kind of container technology from maybe 2003, 2004. So they were kind of quite early adopters. Obviously, if you can, use bin packing algorithms to put as much or as many services on a single box, that's going to be a lot more efficient, as opposed to having 18 servers all with 20% utilization and resource usage. So Kubernetes, originally developed by Google, it kind of went through different iterations. They had an internal cluster management system named Borg, which had some of the components that made cluster management simpler, and then sort of as that kind of bedded in and kind of got more and more use, the Amiga scheduler, so making sure that services are split evenly across different machines in the cluster, so that if one box blows up, Gmail isn't going to go down, for example. And took all of this learning, all of these features, and basically shoehorn them into what we now know as Kubernetes. And what is Kubernetes? Well, it's an open source system for automating deployment, scaling, and management of containerized applications. So if you look back at this diagram, Kubernetes, for the most part, orchestrates this top layer, but with various sort of feature sets, etc. It can be used to scale out the bottom two layers, or the bottom three layers, sorry, so that as you need more and more apps, you can get it to scale up more and more servers, and scale down as required. So that's all well and good, but why would I be interested in K8s? It's a lot of it's a lot of buzzwords. It's a lot of potentially technology that I can't quite get my head around. Certainly, I've not looked into how kernel namespacing has been implemented. I just know that it exists, roughly what it does, and that it's really damn good. But what kind of things do you get out of the box with Kubernetes? Well, if you want to, automated rollouts and rollbacks. So if you want to upload or deploy a new version of your system, you can update a file or even by CLI APIs, and that new version is safely rolled out. You can weight it, so only 20% at a time, one instance of the app at a time, and then if it's detected that it's not working correctly, then it will automatically roll back for you. So the impact to your customers is going to be greatly reduced. Load balancing, service discovery, essentially how multiple instances of a service can talk to instances of another service. How do I allocate storage? Excuse me again. It manages hard drive allocation or partition allocation, configuration entities, so secrets, configuration maps. It will try and put a reasonable number of apps, services, containers onto each node as makes sense. You can tell it to evenly distribute across your stack. You can tell them that you don't want your database ever residing on the same machine as your web front end, and other sort of items like that. You can run jobs, sort of one-offs. You can run scheduled jobs, IP v4, v6 capable. It can scale horizontally. It's self-healing, which feels like sort of a massive snake oil alert, but fundamentally the whole idea of Kubernetes is that you define what you want your cluster to look like via manifests. So I want this, excuse me, I want this service running X number of times, and Kubernetes stores what the state that you want and ensures that the real world reflects that state. So if someone goes in and accidentally deletes a container, it will realize that's happened and then fix it immediately. Give or take. But the most important bit is that it's designed for extensibility, which is kind of why we're all here. There's more on that later. You can run it anywhere. I know that's a claim that a lot of tech stacks and vendors and the like kind of claim, but you can run it pretty much everywhere. So most of the major cloud providers offer managed services. So I want a Kubernetes cluster, and one will appear. So you can roll your own if you're so desired. If you're not in the cloud, so you can run it on bare metal, virtual machines, Raspberry Pis. There are a number of blogs and articles about people creating like a 5 Raspberry Pi deep Kubernetes cluster. I'm not sure what the collective term for Raspberry Pis would be, but a punnet. You can obviously run it on your own laptop, whether that's in virtual machines or sort of Docker desktop if you're on Mac, or Docker Community Edition if you're running on Unix or Windows. Oh no, actually, sorry, tell a lie. The Mac version of Docker, so Docker Desktop, does have the ability for you to spin up a Kubernetes cluster inside of it. I don't know if other operating systems have that capability. I'd like to think so. That's a failing on my research. I can only apologize for that. You can download tools such as Minikube or Kind, and there are numerous others which essentially spin up a Kubernetes cluster on your machine. Very quick, very simple, fairly resource light, which is pretty handy. And you can also run it in wardrobes, funnily enough. Yes, wardrobes. Well, not really wardrobes. Kind of, if you can't afford a server cabinet, or you happen to have a wardrobe that's too big or heavy to move, then maybe you can just facilitate it instead of trying to hang up 3 t-shirts that you actually own. And if you do have a spare wardrobe, you can go at it with drills or jigsaws, with what was initially a really good plan of a really small hole, but then it turns out that plugs don't fit through some really small holes, and cutting out a dirty great big hole in my wardrobe made more sense than cutting off the power supply and rewiring it. Yeah, anyway, so let's get back to this whole extensibility thing. Pretty much with a big asterisk, obviously this is why we're here. You can get Kubernetes to do or run anything in whichever way you see fit. So writing, for those that have, writing Kubernetes manifests can be repetitive, it can be somewhat painful, but you have sort of tools such as Helm, which wrap up all of the underlying manifests and Gumph that take forever to write and get correct, in a very succinct, still Kubernetes-esque way. But you can say, you know, I want a PostgreSQL cluster with X nodes, and each node needs to have 50 gigabytes of hard drive. You know, that's defined in maybe 15, 20 lines of YAML. You send it to the cluster, and then in a matter of moments, you have a connected, available Postgres cluster. You can write your own, they call them charts, but your own definitions for Helm. If you haven't checked them out, it's really cool. Service meshes. So Kubernetes does have a sort of level of service discovery. It is fit for purpose, but at a production, in a production kind of environment, you kind of want to be going a little bit deeper than the kind of basics that Kubernetes gives you. And two good ones, there are several, Istio, Linkerd, so you can connect all of your services nicely. You can configure them to use SSL, TLS without having to do any additional configuration to your application. So security out the box, failover, you can route it between clusters, you can set request retry, so if a service has gone down momentarily, you can get it to back off and retry. Networking plugins, so a lot of the cloud vendors will throw in their specific variant of the network plugin so that you can connect to, so you can easily spin up a network interface. But there's a lot of really cool stuff you can do with some of them. The feature sets range quite a bit between all of them. You can do sort of network level ACLs, to name one example. The whole ecosystem is really decent. So storage plugins, so essentially you can just say, I want 50 gig of a thing, and it's down to the administrator of the cluster to decide what kind of storage that is going to be, whether it's on disk, whether it's an Amazon EBS volume, whether it's an S3 bucket or other cloud vendor terminologies that are available. Postgres, databases. A lot of the big database players now have ways of spinning up clusters, instances of their databases using custom operators, TLS, SSL, certificate management, etc., etc., etc. It's a really rich ecosystem. Sorry, let's have a drink quick. Resources. So when we're talking about resources in the Kubernetes world, it is essentially an entity that lives within the cluster and is managed by an API. Kubernetes has tens out of the box. So pods, which essentially a container. You can have multiple containers living in the same pod, and they share various resources, network IPs, etc. Configuration entities. If there's third party, such as if you install a third party plugin such as Istio, their virtual services are defined as resources, and obviously if you create one yourself, that is a resource. So we're getting there now. Custom resources, CRDs, are essentially the specification for a resource that doesn't come with Kubernetes out of the box. That specification defines the fields that make up a particular resource. A controller is the API mentioned on the previous slide. It's essentially an application that receives updates about your custom resource, will potentially validate it and ensure that what you've requested is reflected in, the real world. Then you also have admission webhooks, which are kind of entry points before you get to the underlying controller, where you can do a number of different things, such as validation. So ensuring that someone hasn't said, I want dog number of instances of this application running. That's a super noddy example, but and sort of setting default values as well. So, you don't necessarily want to have to write out a 100-line specification if you're only really caring about one specific entity. So why would you create custom resources? Well, if someone else hasn't already, business limitations. So, you can't use open source tools using certain licenses. If you can't use open source tools, then why are you using Kubernetes? There are other options, business specific use cases, or as what kind of got me into creating custom resources. Oh yeah, wouldn't it be really cool if rather than managing stuff via Terraform or CloudFormation, sorry, how about we just manage everything in Kubernetes? And so a lot of the tutorials and examples will kind of show you actually just improving some of the default resources that already exist, making it a little nicer, a little bit sort of closer to your use case. So Kubebuilder, as Steve mentioned at the top, what is it? It's a framework for creating these APIs using custom resource definitions. There's a lot of moving parts that go into creating custom resources that if you had to do from scratch, you would just never do it. So this framework provides a lot of tools, a lot of scaffolding, and really, really nice documentation as well to allow you to do this stuff, get your idea into a cluster pretty quickly without necessarily having to worry about the entire Kubernetes ecosystem. You can kind of really drill down to what you actually want to focus on. Getting started is fairly easy. You download a binary. You then go and create a Go project, initialize the Go modules, which is package dependency if you're not familiar with it, and then you need to initialize the project, the domain for which is fairly. It can be pretty much whatever you want, providing it does sort of conform to a DQN format. So once you've got your project together, you can use the Kubebuilder API, CLI rather, to create an API where you define a grouping, the version of this API. So typically you'd probably be throwing it out as a v1 alpha, etc. And then the kind, which is the name of the thing that, the name of the custom resource you're creating. You'll then be prompted if you want to sort of create the resource specification and the controllers. Say yes, and it then scaffolds a whole bunch of stuff for you. Can take a bit of time, so I've done that ahead of time, so you don't have to sit here and watch me download various bits over what is probably a flaky internet connection. So hopefully you're all still awake and following on. So this custom definition that we're creating is going to be what I've called PG secrets. And what that is it is a, a lot of it is a way of creating a Kubernetes secret resource from values in a database. So there are a number of tools, systems, etc., that do this for you already. So HashiCorp Vault is a good example. But I thought this was a relatively nice way to kind of cover a lot of entities. So the idea would be that you could say, okay, well, I want a secret to be populated from rows in my database with these keys. It will then go and create a Kubernetes secret from that, so that you can then attach that to your pod. Yeah. So hopefully the zoom is okay. When the code actually comes up, it will be zoomed in a lot further. So hopefully, from the viewing this tree structure, it won't be too horrendous. So when you run that create API command, it will create an API folder with the version that you want, and then a whole bunch of scaffolded properties. So you have your kind here, which just inherits from a number of Kubernetes resources, and then there are some nested structs containing the actual specification and the status. So that's just some computationally generated values. So prime examples would be if you have a pod that is failing some health checks, those failures may appear in pod's status section, and then some other bits which it's all stuff that the API needs to have access to, but you don't need to focus too much when you're first kind of getting into this. There's so you have a configuration file which has a whole heap of manifests for creating various resources, roles, services, the deployment for your actual controller, various other bits and pieces, and then the controllers package, which the crux of these controllers is the reconcile method. This is essentially invoked whenever Kubernetes deems that the real world state and the state that it is aware of changes. So when you create a new resource, or when that resource is updated, or depending on how things have been configured, if you end up creating nested resources, if you delete that nested resource, this gets called and then recreates it. So just make sure that everything that should be is. The other thing to call out at this point is the makefile. There is a ton of commands in this makefile which make the whole building, deployment, generation of manifests just so much easier. Under the hood, it uses the customize framework, which is essentially a templating engine. for Kubernetes manifests, so that you can you don't have to keep defining the same. You don't have to define the name of your entity or the namespace of your entity 100,000 times. You can just define it once and then reference those variables in the other manifests that you're writing. So that's kind of where you would be if the slides, if you'd followed along with the slides. So this, oops, not used to using a touchpad. So our specification. Well, what's our specification going to contain? Well, if we wanted to if we wanted to set the name of the secret to a particular value, we can define that. But as you can see, that is an optional field. These markers are used throughout this Kubebuilder project. And again, it's all scaffolding based, so it creates a whole bunch of, does a whole lot of the heavy lifting for you, fundamentally. So then we have a data entity, which is a list of items, and items are simply a key, which references a key in the column in the database, and the name, if you wanted to change the name, the corresponding key in the secret that's generated. You know, so a good example would maybe if you have lowercase value in the key column, but you need it to be uppercase in the actual secret. You can set the name there. And then, yep, that's not on that step. So I rushed through that a bit because apparently I've already talked for the allotted amount of time. Rush. So hopefully you can see that. So anytime you make a change to your types, the specification, you need to run the generate command, which will scaffold a bunch of panicking. Sorry. It scaffolds a bunch of manifests, specifically the custom resource definition manifest, which you then later go on to install. This is where it all goes to pot. Good. I'm also not used to using this keyboard. Yay, demo gods. So, okay, so our custom resource definition has been defined. We've written it. We now need to write the controller to actually act upon when
I can't hear you, Rich. I don't know if something's happened to your audio.
Yeah, I think it has dropped out, Rich.
Yeah, I had a click, almost like something disconnecting.
Is it Bert? Did Bert do it?
You need to get Kubernetes to fix that.
Can Kubernetes do that?
If someone writes the operator code to do it.
Yeah, exactly. Am I back?
Yeah,
It's
you're back now, Rich.
Nice
Cool.
one.
So yeah, sorry about that. There's a good chance that my typing will now knock out the microphone. I'll try not to type too loudly. So finalizers. Finalizers are useful if you are creating sort of nested resources. So in our case, where we're going off to create an actual Kubernetes secret, because deletions occur asynchronously, we want to be able to say, well, let's not delete the kind of master resource, so the PG secret in this case, until the underlying child resource has been deleted, just because otherwise you're going to end up with orphaned resources. And essentially, all that is an annotation, a label that states that a finalizer has occurred. So anything, a finalizer has been defined so that any child resources need to be sort of cleared up. So it just kind of pauses here for a bit. Oh yes, that's the adding if it hasn't already added. So the object at this point is being deleted. So delete the child resource, remove the finalizer, so then Kubernetes can remove the resource from its data store. So if we're not deleting it, we are updating or creating, upserting, if you will. And then once the underlying secret, the Kubernetes secret has been created, then we can just kind of say, hey, we're done. So we could throw back an empty result with no error, and Kubernetes is happy until the change comes in. For this particular use case, you can tell it, I'm telling it to re-queue, so essentially poll every 5 seconds, so that if the value in the database changes, so the secret that we're putting, the secret value that we're pulling in changes, that will then be persisted through to the Kubernetes secret that we're creating. Oh yeah, delete chart. Yeah. Upsert secret. This will all be going up on GitHub if you want to take. Please take a look at it later on. But this is just wrapping the database call. So we have the name of the entity that we want to create. We check to see whether the Kate secret in question has been created or not, or whether it exists. If it doesn't exist, if it does exist, then we update its data value to contain key value pairs of the values that we are defining in the database. It will update the underlying secret. If an error has occurred that isn't simply this secret doesn't exist, we'll return it, create the secret record. So the set controller reference is particularly important if you are creating nested entities. It basically means that the secret that is generated, the Kubernetes secret, has a reference back to the master secret that we're creating, the PG secret that we're creating, so that the reconciliation events will trigger if something occurs to that secret, essentially making sure that the state is kept up to date. Create that resource, and yeah, that in that kind of whirlwind nutshell. I talked. There was too many slides at the beginning and not enough time on this, so I can only apologise. But that's kind of where we're looking at. And if oh no. Yeah, okay. So just entered a bunch of commands which will install, it will regenerate the manifest in case they've changed, build the Docker image based on everything we put in here, publish that Docker image to the repository of your choice, GitHub, Docker Hub in this case, and then we'll deploy it to the cluster that's running behind me. There are a few other bits which I haven't been able to cover for the aforementioned too many slides at the beginning. Oh, cool. Oh, screw you, demo gods. But I will put this. I will put this up. It is definitely 100% working. Oh, let's just end this here. I think it's gone really well. I'll be putting if anyone's in the Slack channel, in the Slack group, I can answer any further questions there later. Any things you want clarifying, such as this, the last hour of your life, how to do various different bits and pieces. I'm happy to answer any questions that do come across.
Yeah, I've got a couple of questions, and Nigel, I know you've been doing a bit of work around this as well, haven't you? Building a Kubernetes operator, so we could maybe find out a little bit about that in a minute. But just a quick one from me. Just made a note of something. Yeah, have you ever written custom resources for a production environment?
Yes, and they work, which may be surprised to hear. So oh, wouldn't it be cool if a use case mentioned earlier, one of my teammates suggested that it would be really handy if we could create AWS Lambda functions from Kubernetes resources. So I went away and did exactly that. So we have all of our Lambda functions for one of our products are all defined as Kate's manifests. They are it has polling for S3 buckets. So our build pipeline constructs the kind of the Lambda artifact, throws that into an S3 bucket, and the the controllers, just sort of sitting there waiting, updates the manifest in GitHub, and then other tools that we have running on the system pull down the updated manifest. So GitOps as an overarching piece of terminology. Yeah, updates Lambda functions. I am going to be open sourcing it soon. There are, can't remember the name of it. There's a couple of operators that provide Kubernetes custom resources for creating AWS and some GCP resources that don't include Lambda. So yeah, and you can kind of see what the less simple resource looks like.
And you still got your job, so it must have gone okay.
Well, I might not after this, but yeah.
How you getting on with it, Nigel?
Yeah, so thanks for the talk, Richard. Yeah, so it's all quite new to me. I mean, I've been doing stuff with Kubernetes as part of an open source project. So I work on a project called Ageria. It's open source. We do all sorts of things, and we're quite a small team, so we have to get involved in everything. So one of the tasks was to write an operator, because we want to make it easier for people to take our software and deploy it by defining, for example, a custom resource, which, if you like, is a model of how you want that application to be deployed and to behave. And probably that's one of the hardest things in many ways, is looking at how you model that application in terms of the custom resources, whether you use one custom resource, multiple custom resources, how you break it down. And also for us, how far do you want the functionality to go? You know, and we've decided to start off, I say we, it's really just me, unfortunately. We've just started off really at the top level of, if you like, how we break down our application deployment rather than to get too complicated. I initially wanted to get quite complicated, and I figured I need to start simple. So that's almost been the hardest bit. I didn't know Go when I started, so I've been trying to sort of, well, Google and do bits as I go, because with operators, there are frameworks. There's tooling, for example, Operator SDK is what I'm using, which comes from Red Hat. And that started off, I suppose, trying to do some of the same things as Kubebuilder, and then Kubebuilder came along, or it was already along, and now Operator SDK actually uses Kubebuilder. So it just adds a pretty thin wrapper and does a few other things around what we've just seen from Rich. So because of that, I'm also looking at Kubebuilder. So I'm looking at some of the annotations, like adding extra status fields when I look at the state of an object. But if I'm honest, my operator at the moment has so many to-dos. You know, we talked about finalizers and things, and I've just got need to write my finalizer. So it's still very much work in progress, sort of iterative. What else is it worth talking about? Like the returns and the requeuing. That's something I didn't appreciate initially, in terms of when to return from the reconciliation loop and what to actually return. If you're creating child objects that will take a while, or then it makes sense to not come back and look straight away and do that. When you're writing the reconciliation loop, I realized to just do a small amount of work each time and then return, rather than try to do too much together. So I think that made sense. Yeah, that's kind of it. As I said, it's not that I'm blocked on anything at the moment. It's just it's quite slow progress in some ways, but getting through it.
How does that all sound to you, Rich? Is that any?
Yeah, it's, you know, yeah, it's. So I mean, anything in the Kubernetes world, you know, you can go really far, you can go really deep, and I think one of the principles of Kubernetes is to try and abstract away all of the complexity that kind of occurs behind the scenes. So there's an element of you know, custom resources or operators kind of doing that for the end user, but fundamentally you have to kind of think about how you make your life as a developer easier. So, you know, you could have a honking great big reconcile function that does all of the things, and you know, it can get unwieldy. You know, as you know, anyone who's written code, you know, can start sort of hitting 100, 200 lines in a function, or yeah, it gets pretty hard to manage. But with this sort of framework, you can kind of use it and separate out your concerns, so you can have smaller, succinct entities, which your operator as a whole can kind of go in and say, okay, well, I'll go off and create this thing and that thing, but multiple controllers listening to this thing and that thing, so that you only, go to your storage controller, for example, and the only stuff you need to worry about in there is the storage stuff. You go to deployment wrappers or things like that. Yeah, but yeah, I found it really really nice to use. I had a brief look at the operator SDK. This was a while ago now, so I can't remember exactly my reasons for kind of steering away from it. But yeah, Kubebuilder and the documentation as well. Let me just share my screen again. I've got some links.
Yeah, I think initially Operator SDK went their own way, and so it was that or Kubebuilder. And as I said, now they've kind of just adopted Kubebuilder, so now it's very similar. So
yeah. So yeah. Am I showing? I'm presuming I'm sharing. Yeah, cool. So yeah, Kubernetes IO for anything Kubernetes, explained in a much more succinct way than what I did. The repo for Kubebuilder, the documentation for Kubebuilder, which is, if this is something you're thinking about doing, hopefully I haven't put you off. Definitely check it out. It holds your hand reasonably well through the entire process. And then this link is going to, once I've kind of gotten my life together, this is where the code is going to be held. So just compile Brighton Gophers. Yeah.
Yeah, on the docs, I was trying to add these extra print columns and I couldn't get it working. And I went through and through and through, couldn't work out what I got wrong. And then I realized that it was because I had put a priority entry on and it was a non-zero. So I think it has to be 0, maybe 1. If it isn't, it only appears when you do a wide listing. And I thought, oh, I'll raise an issue against the documentation. I go back to the documentation and look, of course it's there in black and white. I just obviously missed it when I was reading through. So yeah, must read the docs. I'm not great at that as a developer.
Yeah. Oh, I mean,
or write in the docs.
Even the greatest docs, have things in there that, they can't. A document isn't necessarily going to cater for everyone's sort of reading style and bits and pieces like that. But whilst we were talking, I've kind of switched through different branches and hopefully have it now running on my cluster.
Yay.
Excuse me, and it's just the print column bit that you mentioned.
Oh yeah, cool. Yeah, that's quite nice because it just gives you that extra context when you just want to do a quick look at what you've got.
Yeah.
So you can add your. I haven't figured out what other status I'm returning yet. As I said, it's still very much work in progress. And cool. Exactly, you've got sync status. Lovely.
Yeah. So yeah, just so the kind of handy things. So at Futrli we use something that does something similar, but it doesn't use a database. And one of it was who created it originally, GoDaddy. And one of my biggest bugbears was if there was a missing key, you just wouldn't know. It would just fail. So that in particular was
I think it's nice to see that at the summary level rather than having to delve into the operator logs, which you may or may not have access to.
100%. Because yeah, you can then quite easily oh god, keep talking amongst yourselves.
I think the admission control is interesting as well. That's also on my to-do list in terms of the extra validation, basically. But
yeah, the again, that was all stuff I wanted to talk about. You know, because of all the scaffolding, you can say you want a webhook, and the vast majority of the webhook entities are kind of put straight in, and then you can just kind of go in and define your so essentially validate the resource on, delete, on, update, on, create, etc. But again, another thing I find really, really helpful is you can pinpoint the exact field or index if it's collection, and get specific error messages rather than just no, sorry, something's sort of gone wrong. So good. Hopefully I can do this. Oh yeah, invalid. So oh, good.
Do you use any other operators that are, kind of out there in, open source domain or products that you find either particularly good or particularly bad?
Sure. So we use Istio for our service mesh in one of our clusters, because we have particular use cases with multi-region clusters, so we can forward requests through to our kind of main, so we can have it geographically located closer to the end user, but and then use the cloud provider's backbone to get a quick connection to the database, so that we can manipulate it in the master, the primary database store, and then have that sort of replicated down. We also use Flux for so Argo CD is a kind of alternative, but basically the whole premise is that you define the state of your cluster in a GitHub repo, and it's constantly polling that GitHub repo, and if new versions are created, it will pull down those changes and ensure that the cluster is running that version of the app, or that number of replicas, or that storage configuration, and it basically means you just kind of have the audit, all of the good stuff that you kind of have with development of GitHub, in making sure you can track changes and PRs and all that kind of good stuff, but for your actual configuration of your services, rather than just throwing it over the wall. What else do we use? Yeah, so the GoDaddy operator we use for sort of secrets, external secrets it's called, that pulls in from Amazon's system manager. I haven't used it personally, but the Vault secrets operator is, I've heard very, very good things.
No, that's helpful, just in terms of kind of looking for example, because I'm not working in the production space. I'm only working in kind of the development of the operator space. So it's kind of interesting to see what you see in terms of things that are actually useful out there as well.
Yeah, well, I mean, because it's such a wide and vast ecosystem. Yeah, there is that risk of kind of drowning in stuff, and especially if you look at service meshes. So Istio is I don't want to say de facto, but it is very, very, very popular for good reason. It can do all of the things that I think you could possibly ever want a service mesh to do. But sort of using Istio as inspiration, I think it would take a long time just to kind of absorb, even a quarter of what's in there. But then you sort of have other things like Linkerd, which does a subset of has a subset of features, but it does it really well, really succinctly. If you just want to throw a service mesh on your cluster without having to worry about the respectfully large overhead of Istio, then you can absolutely do it. I've got Linkerd running in the wardrobe. Lots of nice stuff there. As for kind of smaller things, I mean, once I open source this Lambda operator, then that may be useful for inspiration. But I mean, to be fair, a quick Google search, you'll come across countless.
Yeah. I did a bit of a survey, kind of before I started. I looked at, I forget which ones they were now, 6 or 7 different examples. Really not so much in terms of specifics of the code, but just to get an idea of what people were doing out there. So that was good, but that was from my development perspective, as I said. So always good to get perspectives. I think the other thing is, certainly in my team or people I work with, it's also about trying to convince them that although Kubernetes is really smart and clever, some of the basic principles, like you were talking, all you're trying to do is really define how you want things to be, right? And I think I take it like Captain Picard, make it so, and that's really all that Kubernetes is doing. All that gumph that we're developing is just about making that happen. So trying to encourage them to think about it as it's trying to take that complexity away and do it for you. So on one side, we're talking about how we deal with that complexity to make it simple so that then the users can take it, but then it's always contextual. So there was always layer upon layer upon layer. So but trying to convince people that it's not really horrible complex black art is sometimes difficult, but we're trying.
And especially if people are quite deeply adverse to YAML, which rightly or wrongly, presenting someone with a 60-line YAML file for here's how here's the template for the thing you want to deploy, that kind of.
And it gets even worse, I think, with YAML with Helm charts and functions and then trying to debug them. Sometimes that's a bit of a pain, but hey. Yeah,
I think if you're kind of in the operator space, operator world, I think personally, Helm charts are incredibly useful.
So actually it was Helm charts we developed first for setting up kind of demo environments. This isn't production stuff, right? This is more about demos. And it's great at aggregating all those pieces together that you need in order to run those demos. That's where it all started from. And I think even with the operator, what we're doing really with the operator is saying those product specific things about how we set up our kind of metadata ecosystem. That's what the operator manages. But you've got all this other gumph when you're really deploying, or you're, in my case, setting up a demo, whether it's LDAP servers or all kinds of things. And actually pulling those together with Helm is quite useful. So, I think some people have had the view initially when operators came out that it was kind of replacing Helm. I heard people say that many times. It's like, no, it isn't. No, it isn't. They're doing two different jobs. All Helm is doing is basically it's basically a template engine. So it's just taking all your YAML fragments, doing templating, packaging it together and shipping it off to the server. Now that we've got rid of sort of Tiller and stuff. So I think I see them as two very different but complementary things.
Agreed. Agreed.
Cool. So if there's no more questions, we'll look to wrap up. Rich, fantastic. Your little virtual clap. I'll give you a one there. Excellent, really excellent. If it'd be possible to put those links into the Slack channel, that'd be great. Get those shared far and wide.
All of that, all of this stuff. Yeah, I'll be adding them in. I'll be updating once I've kind of pushed everything. I'll chuck in information to the README so that you can have a play with it at your leisure.